So we have to find the coordinate of A. So first thing we have to do here is to introduce the log, the original, because this is a log graph. So if you have a graph that goes this way, that intersects at 1, this is a log graph, log AX, the base is A, where A must be greater than 1. So the base of this logarithm function is more than 1. Why, if you have almost the same thing, this is log, the same log AX, but in this case, A must be between 0 and 1. So any base between 0 and 1, the graph will move this way. So that is it. Almost the same, if they are the same. So looking at this, you see that this point has common points here, because that with 1, this minus, so the same thing. This is the common. So if I call this log AX, log base AX, this is now log. You know, for this to be, they are the same, and for this to be greater than 1, and this is between 0 and 1, this should be A minus 1x, or you write it log 1 over AX, for them to be the same. As you can direct that they have common points. So that's it. So coming here, there's what we call transformation. So if you have a graph y equal to fx, and I have another graph y equal to plus or minus a plus fx plus or minus b, meaning that we'll get this second one from the first one by shifting to the, shifting vertically. So this A is vertical shift. It could be down, minus for down, plus for up. YB is the horizontal shift, which could be left or right. So if it's minus, it's right. If it's plus, it's left. So that's how we got P of X. That's if you shift this, check. This is a 1 point. If you shift one unit up, so my A is 1. So you see that PS is now 1 plus log AX. So with that, we can now solve for what we are looking for. We want to get the point of intersection of this and this. But first, we need to get the exact, because we want to get the exact value. So I need to get the value of A. We can get the value of A. How do you do it? Look at this, the graph of QX. You see that we have an important point. This is 3. That's because this is 2, 1. So you see that as if you have Q of X equals log base AX. So at 3, 1, you see that our y, that's Q of X is 1, y our X is 3. So what do you have to say? You see that A is now 3. So our base is 3. So what do you do? At the point of intersection now, you equate the two, P of X and G of X. So at the point of intersection, so we now represent A with 3. So let's do it in another page. So this is log base 3 x. Why this is now 1 plus log base 3x. Why this is now log 1 over 3 as base 1 over 3x. So we now have at the point of intersection at A, what do you have to say? P of X is the same as G of X, they are equal. So P of X is 1 plus log base 3x equals G of X is log 1 over base 1 over 3x. And we know from our laws of logarithm, you can write this as, from laws, we've done it. This is now minus log 3x. Yes. But this is log 3 minus 1x. So if you remove this, you reciprocate. Bring it here, you reciprocate. So minus 1 over 1. If you reciprocate, you still get minus 1. And bring it here. That's why it's minus 1. So 1 plus log 3x. So we can collect like terms. So this one goes over here to be log 3x plus log 3x, which is 2 log 3x. While this one goes over here to be minus 1. So making log 3x the subject of formula, this is minus 1 over 2. Therefore, x is now 3 raised to the power minus 1 over 2, which we know is 1 over 3 raised to the power half, which is 1 over root 3. And if you rationalize, if I want to make it to the simplest, we have root 3 over 3. So that's the value of our x. To get y, you choose any of them and substitute. So choose any of them and substitute the value of, that's either p of x or g of x. You substitute the value. So let's choose p of x. Therefore, p of x is now equal to 1 plus log 3. Our x is 3 raised to the power minus half. So I will use this so that it will be easy for the answer. So which is 1 plus log, that's 1 plus, we used our third law. So this is 1 minus the power here, minus half log 3. So which is log 3 is 1. So 1 minus half is half. Therefore, the coordinate of A is root 3 over 3 comma half. So that's our answer. So it's a very nice and tricky question. Thank you.